You want to count the number of subsets of the set of 1 to 2023 whose sum is 3 mod 4, yeah?
Yeah.
So the claim is the answer is 2 to the 2021. That's how many there are. Okay. So basically the idea goes like this. So do you know that the number of subsets of a set is just 2 to the power of the size of the set? So that's a kind of a what you would call like a textbook result. So basically where you get the power of 2 comes from is like if you take a subset, right? Every element can be in or out of the subset. So it's two possibilities for every element. So then the total number of subsets is 2 to the power of the number of elements. Okay, so the total number of things here is 2 to the 2023, right? That's the total number of subsets. So the answer has to be less than that, right?
2 to the 2021.
Okay. So 2 to the 2021 is exactly a quarter of 2 to the 2023, right? Okay. So we just need to prove that the number of sets that the sets we want is a quarter of the total number of sets. Okay. This comes from two facts. Okay. So the number of sets which sum to 1 mod 4 is equal to the number of sets which sum to 3 mod 4. Okay. Okay.
Yeah.
And also the number of sets with and yeah, and the number of sets with an odd number of elements is equal to the number of sets with an even number of elements. Okay, let's take it one step at a time because I'm gonna kind of lose track. Um, so okay, so how do you prove that a subset with sum 3 mod 4 is equal to the number of subsets with sum 1 mod 4, right? So you can define a bijection. So if you have a subset X whose sum is 1 mod 4, right? You can define a bijection which takes this to a set to the complement. So let's call this set S, yeah? You can take X to the complement of X in S. Okay. Does that make sense what the complement is? It's everything except for the things in X. And this set has the property that it has a sum 3 mod 4. And the reason is because the total sum of S is a multiple of 4. Right? Because 2023 plus 1 is a 4. 3 plus, you get pairs, multiple of 4. Okay? So this is a bijection, okay? Because you can obviously go backwards by just taking the complement again. Right? So it's a bijection between the sets with sum 1 mod 4 and the set with size 3 mod 4.
It's like this much below that value.
Okay, so because they're in bijection, it suffices. So obviously, if the sum has odd sum, it has to be either 3 mod 4 or 1 mod 4, right?
Yeah.
So this is now the problem becomes to count the number of sets whose sum is odd. Yeah, because now your thing is just half of that answer, right? Okay, so how do you count sets whose sum is odd, right? You can just take all the elements mod 2, right? See if they're odd or even, right? So from 1 to 2023, how many odd numbers are there? How many even numbers are there?
Oh yeah, there's a story about killing that we have to read in. What's that? 1011.
Yeah, so 1011 even and 1012 odd numbers, right?
Yeah.
So to get an odd sum, right, you just need any subset of the even numbers plus an odd-sized subset of the odd numbers, right? So any subset of 1011 we know is 2 to the power of 1011, right? And an odd-sized subset, so an odd-sized subset has there's the same number of odd-sized subsets as there are even-sized subsets. And the reason is because if you take a subset with odd size, right,
I don't think killing them
and the total size is an even size, right, then the complement is now even. Sorry, what?
Wait,
Hold on. Wait,
How?
wait,
No.
what?
You don't have time to write quick quiz now.
Hold on. Is it 1012 odd
It's like,
odd
I'll kill
things?
all of them.
Wait, what's going on here?
What if I
So you can any subset of the evens, yeah? And you need an odd number of things from the odds. Okay, so the number of subsets. Wait, would that give us the right answer? If the number of subsets with odd size is the same as the number of subsets with even size, then it's 2 to the power of. Yeah, then it's 2 to the power of 1011, right?
Seeming like it's your fault.
Okay, and then you times them together, you get 2 to the 2022, and you halve it. You halve it because you only want 1 mod 4, not you only want 3 mod 4. Then you get 2 to 2021, right? So we just need to prove that the total number of subsets whose size is odd is the same as the total number of subsets whose size is even, right?
It's like this woman kills her husband by using a leg of lamb to like cause like.
I thought we kind of we have proved this.
And then when the police officers are over, she gets them to eat the leg of lamb.
So there's 2 to the 1012 total subsets, and half of them have even size and half of them have odd size.
Like after she kills her husband, she goes to the grocery store and buys food, and then comes back, sees her husband dead, and cries.
What the? Huh? He cries. That is, I think, called.
She's gaslighting herself.
Yeah.
And then when the police officers come over, they like eat the leg of lamb
Oh my gosh.
while talking about how the weapon would be under their noses.
Do you remember how we proved the size of the number of sets with odd size is equal to the number of sets with even size?
No.